This is the second part of the truth table section on the logic unit. So my plan is to do this one truth table, this to kind of review it, and then show how to show two statements are equivalent. All right, so first let's do this one. I will mention that I'm going to gauge, I may actually repost this later in the semester if I get a lot of questions about truth tables. I may try to add some stuff to it or post maybe even a third truth table video that's answering questions. This unit is a little bit trickier, so I thought that maybe there might be room to do that. I'll have to see how things go. Anyway. So we're going to do, as you can see, inner parentheses is P and Q, and then we got and negate P in the outer parentheses, and arrow finally to Q, negate Q. So we're going to do P, Q. By the way, the statement, know your P's and Q's, actually refers to know your pints and quarts. It's actually not anything to do with truth tables. Anyway. So what we're going to do is go P and Q, the inner parentheses. And actually, let me go ahead, but you can go that route, but I'm actually going to just do the negations first. That might be a little easier. So we'll just do negate P and negate Q. Anytime you do a negation directly with the variable, nothing in between them, you can go ahead and do those for free first. Then we can do the inner parentheses. And then we're actually ready to do the outer parentheses, because we will at that point know what negate P is. And then we'll do the entire statement, if I can squeeze it in here, going to negate Q. And of course, we're doing the same pattern, T, T, F, F, T, F, T, F. And again, as mentioned in the first video, that is every combination. I just use that pattern almost all the time. And actually, I will mention that I probably will have to put that on the test in the key or something, this to mention that in the truth table section of the test that you need to go to order, use the order, you know, T, T, F, F, T, F, T, F for P and Q. Although you guys probably, after reading my slides and watching my videos, will go that order anyway. Okay. So the negation of P will just be flipping, so that will now be F, F, T, T, or yeah, F, F, T, T, and this will be F, T, F, T, and then P and Q again comes directly from this. The first one, two truths is true, and then TF is false, FT is false, and FF is false. So again, that's that, TFFF. And because it's just P and Q by itself, there's no other symbols, that it's going to be the same order as the original table. All right, now comparing P and Q to negate P, we look up F. T and F is F. F and F is false. F and T is false. And then F and T again is false. We actually only used the last three rows 3 and 4 on that example. So sometimes you will not use every entry in your table. We only use the result from, actually I guess we did do, I stand corrected, we did do T and F. So we did the last 3 rows. It looks like we did. I'll double check that. T, F, 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 T, F, T, yes. So finishing out, we have to do the arrow, and it's going from this statement to negate Q. So we're going to look up FF, which is false. Or excuse me, true. FF is true. F to T is also true. Third row. Back to fourth row is true. and then f to t, the third row again, is true. So we did actually on this one only use the third and fourth rows. But we got all truths. So we did get another tautology. And we'll talk more about the significance of that in the next section. Okay. Let me define what equivalent statements are. There are a few extra practice problems in the slides if you want to do them as well. But two statements are logically equivalent if the last columns of their truth tables are the same. So I'll repeat that one more time. Again, the key to logical equivalence is if you construct the two truth tables, they should yield the same result in the last column. So, the example I'm going to do, number 12 in our notes, is we're going to compare P arrow Q and negate P or Q. Those are my two statements. We're going to see if they're logically equivalent. Actually, the question asks you to show they're logically equivalent. So it appears that they are. We just have to show it. So what we're going to do, the strategy is this, to construct two truth tables for each statement. And then basically compare the last column. So P arrow Q. Again, it will be true, false, because T to F to T is false. Put that down wrong. And then F to T is true. And then F to F is true. So again, true, false, true, true. So now we're going to do P, Q, and then we're going to do negate P. We don't have a lot of symbols in this one. We got to do negation of P, and then we got to compare the two using or. So now we will make the second truth table. We did P arrow Q. We're going to do negate P or Q. So the first thing we have to do is negate P, which will be false, false, true, true. And then doing negate P or Q, we will look F to T up is true. F or F is false. And I said F to T, really it's F or T, my mistake. But evidently that's true. And then F or F, and then true or true is true, and then true or false is true. And let's compare. So if we look at our two small truth tables, if you look at the last column of each of them, they are identical, TF, TT. So we can make a note to ourselves that the statements are logically equivalent, or even to say equivalent. So the two statements are logically equivalent. Or you can even write it this way. You can compare them using the symbol for logical equivalence is actually an equation with a bar, and it says 3 bars. So that means logically equivalent. So that is showing two statements are equivalent. It also reviews 2 more truth tables. So in a sense, you got 3 more truth tables to look at that I worked out. So that's the start, and I'll see how it goes. If depending on the number of questions I get with emails to in the distance ed course, if there seems to be things that I can address that are common questions, I can kind of just do another video addressing those. I may do that, I may not, but I'm leaving that open opportunity for that to happen. So we'll see how it goes. Anyway, the next unit will be on validity.